Dear students, welcome to s.mathguru classes. So our main discussion is solving the differential equation using a Laplace transform. So we consider this problem. Solve the following differential equation using Laplace transform. D cube y dt cube minus 3d square y dt square plus 3 dy dt minus y equal to t square e to the power t, where y of 0 equal to 1 and dy dt at t equal to 0 equal to 0, d square y dt square t equal to 0 equal to minus 2. Now we want to solve this problem. Solution: this is given this d cube y dt cube minus 3 d square y dt square plus 3 dy dt minus y equal to t square e to the power t. This is third order derivative. We can write y triple dash, and this is y double dash. This is y dash minus y equal to t square e to the power t. Taking Laplace transform on both sides, we get Laplace transform on both sides, we get this t square e to the power t. So we know this in video number 1 it was given. If triple dash given, then we can write s cube y bar s square y of 0 s y of 0 y dash 0, and this is y double dash 0. It was given in video number 1. If triple dash given, s cube y bar s square y of 0 s y of 0, the power of s gradually, triple dash means we write s cube, the power of s gradually 1 decrease, and minus 3, this is y double dash s square y bar s y of 0 minus y dash 0. We get this, and 3 y dash, this is s y bar minus y of 0 minus y bar, and t square e to the power t. We know the original formula, L of ft equal to f of s. If we multiplying this one by t to the power n, then this is minus 1 to the power n d to the power n ds to the power n fs. We know this formula. L of ft equal to f of s. If we multiplying ft by t to the power n, then minus 1 to the power n d to the power n ds to the power n fs. We get this. Now here L of t equal to 1 by s minus 1 we get. L of t is 1 by s minus a, and if we multiplying by t square, then this is minus 1 to the power 2 d to the power 2 ds to the power 2 s minus 1 we get fs. This is 1, and this is dds and dds s minus 1, and this is dds. If we solve directly, minus 1 by s minus 1 whole square. Again, if we differentiate, another minus we get minus 2 by s minus 1, 2 plus 1, this is 3. That means 2 by s minus 1 whole cube we get. If we differentiate this 2 times, then we get 2 by this. So this right hand side directly we write 2 by s minus 1 whole cube, this one. Now our given conditions are, this is y of 0 equal to 1, and this is dy dt, and t equal to 0 d square y dt square t equal to 0 equal to minus 2, or we can write y of 0 equal to 1, this is y dash 0 equal to 0, y double dash 0 equal to minus 2. dy dt we write y dash, and t equal to 0, we putting here 0, and y d square y dt square double dash 0 minus 2, and putting the values s cube y bar s square y of 0 is 1 minus s y dash 0 is 0, y double dash 0, this is minus 2, minus 3 s square y bar minus s y of 0 is 1, y dash 0 plus 3 s y bar y of 0 is 1 minus y bar 2 by s minus 1 whole cube. We get this one. This is s cube y bar s square, this is 0 minus 2, and 3s square y bar plus 3s minus 3s y bar minus 3 minus y bar, this is 2 by s minus 1 whole cube. We get this one, taking s y bar common, then s cube minus 3s square plus 3s this minus 1 y bar common, and this is s square 3s plus 3s, and 2 minus 3 is minus 1, and right hand side 2 by s minus 1 whole cube. We get this. This is, so this will be s minus 1 whole cube y bar, this is a cube minus 3 square b, 3ab square minus b cube, and these are taking right hand side s square minus thrice s plus 1 and plus 2 by s minus 1 whole cube, and s minus 1 whole cube y bar, this is s square minus twice s plus 1 minus s. Here 3s given, I have written 2s, and this is minus s, you get 3s, and this is 2 by s minus 1 whole cube. This implies s minus 1 whole cube y bar, this is s minus 1 whole square, a square minus twice a plus b square, minus s plus 2 by s minus 1 whole cube. We get this, and dividing both sides by this one, y bar equal to s minus 1 whole square by s minus 1 whole cube, s by s minus 1 whole cube, 2 by s minus 1 whole to the power 6. We dividing by this is s minus 1 whole square by s minus 1 whole cube, this is s by this, and this is 6. So this will be y bar, this will be cancelled, 1 by s minus 1, this cancel, and this is s minus 1 plus 1 we consider s minus 1 whole cube, 2 by s minus 1 whole to the power 6. This is 1 by s minus 1, and this will be s minus 1 by s minus 1 whole cube. This is minus 1 by s minus 1 whole cube, 2 by s minus 1 whole to the power 6. So this is our y bar, and y bar equal to 1 by s minus 1, 1 cancel, 1 by s minus 1 whole square, 1 by s minus 1 whole cube, 2 by s minus 1 whole to the power 6. We get this one. Now taking inverse Laplace transform on both sides, we taking inverse Laplace transform, L inverse y bar, and this is L inverse 1 by s minus 1, L inverse 1 by s minus 1 whole square, L inverse 1 by s minus 1 whole cube, plus 2 constant outside, L inverse 1 by s minus 1 whole to the power 6. So taking L inverse on both sides, L inverse this, L inverse, L inverse, L inverse, L inverse, we get this one. So L inverse, we know these two formula, L inverse 1 by s minus a, this will be e to the power at. We know this formula. Again by first shifting theorem, L inverse f of s minus a, if we remove this a, then this will be e to the power at L inverse fs, this one. S minus a, if we remove this a, e to the power at L inverse fs, we get this. Now using this formula, here L inverse y bar means y, 1 by s minus a, this formula, 1 by s minus a, this is e to the power 1t, and using first shifting property, s minus a, we remove this 1, then e to the power 1t, L inverse 1 by s square, this one. And this is, we remove this 1, e to the power 1t, L inverse 1 by s cube, plus 2, we remove this 1, e to the power 1t, L inverse 1 by s to the power 6. Just our first shifting property is s minus a. If we remove a, e to the power at, L inverse, a is cancelled, fs. So here we remove this 1, then 1t, 1 by s square. We remove this 1, then 1t, e to the power 1t, 1 by s cube, and here also 1 by s to the power 6 we get. Again you know this formula, L inverse 1 by s to the power n, this is t to the power n minus 1 by factorial n minus 1. It's our formula. L inverse 1 by s to the power n, t to the power n minus 1 by s to the power n minus 1. Factorial n minus 1 is our formula. So this implies y equal to e to the power t and minus e to the power t 1 by s to the power 2. 1 by s to the power n means t to the power n minus 1, factorial n minus 1. This is t to the power 2 minus 1 by factorial 2 minus 1. And this is e to the power t 1 by s cube. Using this formula, n means 3, t to the power 3 minus 1 by factorial 3 minus 1. And the last one is plus 2 1 by s to the power 5, t to the power 5, 6, s to the power 6, then 6 minus 1 by factorial 6 minus 1. So this is y equal to e to the power t, e to the power t, t by factorial 1, e to the power t, t square by factorial 2. This is e to the power t, e to the power t, t to the power 5 by factorial 5. This implies y equal to e to the power t, t e to the power t, t square by 2 into 1 e to the power t, 2 e to the power t, t to the power 5 by 5, 4, 3, 2, 1. Factorial 5 means this. So this is y equal to e to the power t, t e to the power t. This is t square by 2 e to the power t. This 2 cancel, t to the power 5 e to the power t, and this is 60. And taking e to the power t common, y equal to 1 minus t square by 2 plus t to the power 5 by 60 e to the power t, and this is our final answer. So answer is y equal to 1 minus t, 1 minus t minus t square by 2 plus t to the power 5 by 60 e to the power t. This is the final answer, and this type of problem is most important for exam. This will come, whether this problem come or not, but this type of problem is most important for exam. If in your syllabus differential equation given using Laplace transform, any one problem will come. Be careful. So I hope you are all enjoying with me. If you are all enjoying, then please like this video, and for getting new video at the very beginning, so please subscribe my channel and click the bell icon. Thank you.